everyone and welcome to the iTutorial channel of Tagore PG College. So in today's session we will learn about the computer organization as I have stated it on the board also. So what is computer organization? As you know from the term, computer is there and organization is also there. So in computer organization there are a lot of machines, lot of input output devices, the memories, the processors are also there, and in this subject we will learn how they are coordinated each other, how they coordinate themselves with the other machines so as to accomplish the particular task and to also play their role very well. As you have seen in your friends group, when a task is allotted, all the friends put their 100% and try to achieve the goal with their best solution. So in the same manner, here in the computer organization, all the devices work together, coordinate each other so as to accomplish the task in a better way. So with this, we all know very well, computer does not understand our language, that is English, Hindi or any other your mother tongue. So here are the binary language. Here is the binary language. Here is the machine language which computer can understand. So let's go with the number system. So what is the number system? Number system where we learn how the computer translates his language to our language and how he understands our language to his own language. So in the number system, we will first see there is the binary number system. Binary system is there. It has some digits. Which digits? 0 or 1. Binary language or binary number system constitute of 0 or 1. It means it works only on logic. Means yes or no, or true or false. Or you can say it only works on the symbolic language. And as it has only two types of digits, 0 and 1, so the base of this system will be 2. So the base of this system is 2. In the same manner, there is decimal number system. Decimal number system too. In the decimal number system too, we learn the digits from 0 to 1. There is digits 0 to 9. Means total 10 digits are there. So in these digits, we arrange them differently, like to make the number like 23, 34, 57, like that. And as there is total of 10 digits, so its base is 10. Obviously, the total number of digits present in a number system to represent its whole numbers or all the digits, that is called as base. So the base here is 10. So this was about the two number systems. First is the binary number system and second is the decimal number system. But here there is the question like how computer will understood our language. As I have earlier stated that computer does not understand our language. So how it will convert our language to his language and his own language to our language. So let us see with some conversions. There are some conversions which you can convert from the binary number system to decimal number system and from decimal number system to binary number system. So it is a very easy process. You don't need to hesitate or you don't have to be feared, but just look at the process and follow the same. So here is the first conversion. In the first conversion, we will see how we will convert from the binary digit to the decimal. Like how we will understand the code which is generated by the computer So here is the number. Let us take the example 1. Here is the number 1010. So it is a binary number. How we will know? As 1 and 0 is also present in the decimal number system. So there may be confusion. So you have to put the base here. As we know, the base of binary system is 2. So we will put that base at the foot of this parenthesis, so that it will be viable, or it would be visible that this number is from the binary category. So we have to calculate, or we have to change this binary number to which form? To the decimal form. This base on the foot of this parenthesis stated that the number which will be in the converted form relates to the decimal number system. So here is the process. Just first write all these digits here. 0, 1, 0, 1. From which direction? From right to left. I again say you have to write this number from right to left direction. Just put 0 here, then 1, then 0, and then 1. Okay, so you know the base of binary is 2. So you have to just multiply all these numbers with 2. Are you getting, everyone? Okay, so this was the very simple step you all can do, and after that you have to start powering it. Powering 2. You have to power here. 2's power is 0. Then 2's power 1, 2's power 2, 2's power 3. All done? Okay. Then after that you have to mention 2's power 0 is what? When we calculate the power 0 for any digit, it results in 1. As there is a function like x power 0 equals to 1. It is always 1, whether it is 100, whether it is 99, or whether it is any of the number. So it will result in 1, and it will result in 2. 2's power 1 is 2, means we have to multiply 2 with only 1. Then 2's power 2, it means 2 into 2 is there. Here 2's power is 3, it means we have to multiply 2 into 2 into 2. So here we get the result. It is 1, it is 2, and 2 into 2 is 4 here, and here 2 into 2 into 2 is 8. So you may see a sequence or a journal logic here, like there is 1, and the second step is the double of 1. Then there comes 4, which is double of 2, and there comes 8, which is double of 4. Or generally, if you are solving like a short trick, you can also apply this section directly. But I have taught you how this section came from, or from where this section arrives here. So this is the 1, 2, 4 and 8. I will not eradicate this step because this made us understand about our next step. So our number was 1, 0, 1, 0. So when the number is there, we will multiply this 0 with the 1, 1 with the 2, this 0 with the 4, and this 1 with the 8. So there will be the resultant. 0 multiplied by 1 will be 0. Then 1 multiplied 2 will be 2. Then 0 multiplied by 4 will be 0. Then 1 multiplied by 8 will be 8. So now at the last you have all these digits. Add all these digits, and what it would be? 8 plus 2 will be 10. So this is your decimal number. It means the machine or the computer has generated this code for the 10. Or you can say, if we will pass 10 to the computer, it will code it to this number so that it could understand very well. So we can take the next example here, but in a very simple pattern. Hope you all have understood this very well, and at the last of this session, again I would say that there will be some questions or there will be some assignments for you to solve. So let's take another example, a very short 1 1 0 is there like that. So here is a binary, and we have to convert it into decimal form. So let us take a short trick. I have already explained the descriptive part, how that numbers came here or arrived here. So 0, 1 and 1. So we will multiply it by 1. We will multiply by double of 1, that is 2. Then we will multiply the next digit with the double of this 2, that is 4. So we all multiply. After getting multiplied, what they will be? It is 4, it is 2 and it is 0. And after that we will add them. When we will add them, what we will get? We will get 6, and that is the decimal part of this question or this code. So I hope you all have understood this concept very nicely, and you will all practice very perfectly. So this was the conversion binary to decimal. Now if we want to convert the decimal to binary, how it would be? How we will convert or how we will perform it? It is also a very simple conversion, as in the earlier classes or in your earlier school sessions, you have learned how to find out the LCM. It was a very easy concept, that is the lowest common multiple. So then here you will see decimal to binary. It is a very interesting concept, like you see some logical questions, some reasoning questions are there, and it makes your logic strong. And these concepts become on your text when you practice very well. And so here we had the code 23. We have a code 23, that is the decimal form of a value, and we have to convert it in the binary part. So how we will calculate it? So first of all we will write this decimal part, and then what is the base of binary? Okay, you all will reply it is 2. So yes, there is 2. We will divide this number with the 2 every time. As in the earlier stages, when you have learned the LCM method, you have divided the numbers according to which it is divisible by. But here we have to convert it to the binary. That's why we use the base of binary here and divide this number. There is a little change or the little trick which you have to follow. When we divide 23 by 2, here it will 2 ones are 2 and 2 ones are 2, and the remainder 1 will be there. And again we will divide it by 2. As 23 is not completely divisible by 2, then also we have divided it by 2 and get the LCM or get the remainder here collected. So in the same manner we will divide this 11 by 2, 2 5s are 10, and remainder again here is 2. Then again 2 2s are 4, the remainder here is 1. So 2 1s are 2 and remainder here is 0. Why? Because 2 is completely divisible by 2. And after that we will divide the 1 also. How we will divide 1 with the 2? 2 0 are 0 and remainder will be 1. So now the actual trick or the last point is we have to write these numbers or these remainders that we have collected from the bottom to top direction. So as to collect our code for that 23's binary. So its code will be what? So first we will write 1, then 0 is there, then 1, 1 and then. So it is a binary code of 23. So at any time, whenever anybody asks you how you will convert the decimal to binary, then it is a method you can easily follow and perform it. So let me tell you some questions, or let me give you some assignment which you can work with to make it in your practice. So first of all, there will be binary to decimal. So I write here binary to D, and here is D to B. You all understood very well. B is the binary, D is the decimal, here is the decimal, and here is the binary. So I will give you only 5 questions for each of the section, so that you could make the practice. Otherwise you will forget the concepts that what you have studied, and I will also don't know how you have learned or not properly. So in the binaries, get these questions. This is the binary form, and here you have to convert it to the decimal. So here 1, next. Just get done these questions and check your results by converting them to reciprocal conversion. So here is the questions. These questions are very easy questions. You will not find any trouble while solving them, and also you will get more motivated that you have done this, and surely you will do that. So here is 101 is there, and I'm not giving any troublesome questions or much hard. These are very easy to solve and answer. So you should go with them to make your concepts more stronger. As this is a very knowledgeable topic, as in the further competitions, or in the further computer lectures, or in the further computer generations, when you will study at the different stages, you will find it very easy because you are learning these concepts now. So here is decimal to binary. It keeps your interest and makes your studies more interesting when you will follow it. So here is a 27. You have to convert it to the binary. Then there is a 35. There is no need of much calculation, as this is a very simple calculative conversions. So here is a 15, which is a decimal form, and you have to convert it to the binary. Then there is a 42. So the next is 53. So you all have to solve these questions on your notebook, and you have to practice much more questions for that conversions, and in the following sessions or in the further new sessions we will learn some more concepts related to these conversions, like in floating values, how we can convert the binary numbers to decimal, and how we can convert the decimal numbers to binary numbers. So that's all for today's session. Thank you, and just subscribe and like these videos, and continue to watch more knowledgeable videos on iTutorial of B.C.A College.